This video presents the Wings Health platform for the detection of epileptic seizures on EEG signals and for the identification of potential upcoming incidents in the scope of the H2020 DeepHealth project. Data from different sources such as open data repositories or other DBs, medical devices such as EEG, wearables, sensors, etc. are transmitted to the Wings Health platform where they are analyzed. An interactive dashboard provides useful insights concerning the detection and prediction of seizures to healthcare experts. Now, the main functionalities of the platform will be presented. On the home page, the user chooses between the seizures prediction and seizures detection options depending on his or her preferences. Once the desired action is selected, the doctor's patient list is displayed. The data used in the presented video has been obtained from an open database and consists of EEG recordings from pediatric subjects with intractable seizures. The information displayed for each patient includes name, number of relevant data files, and number of models trained. After selecting a specific patient, the user can access the patient files as well as the models that have been trained for that patient. Each file is stored in .dta format and contains information about the channels which indicate the location of the electrodes used in the examination and the total duration of the EEG recording. If the user clicks on the graph icon, he can view all the EEG recordings of that file. By pressing the Details button, the user can see a specific graph in more detail by zooming in on the desired areas. The user selects the .dta file he or she prefers to training a model. In the training process, the model's parameters are adjusted using annotated data in order to have increased performance in the seizure prediction task. After selecting the preferred files, the user must enter some required parameters, which are the model's name, the channels, the architecture, and the number of epochs. In the advanced settings, the user sets other optional parameters, such as the hardware and the optimizer. As soon as the user clicks on the OK button, the training process begins. When the process is completed, a message of successful training is displayed, and information about the mean epoch time and the mean epoch training time is provided. Just below the patient files, a list of trained models is displayed. For the inference process, the user selects a trained model and then selects the files from the inference. Now the model will make predictions against the previously unseen data using the best parameters from the training procedure. Once the process is completed successfully, the user can view metrics about the model's performance. Among them, there are metrics which evaluate the prediction capabilities of the model, such as the accuracy, sensitivity, specificity, precision, as well as the elapsed time of the model's inference. For example, here we can see that for the selected model, the accuracy reaches 96.5%. The user can also view a list of the inference files annotated with the model's predictions. By selecting one of the annotated files, signal segments are displayed in green and red, indicating the interictal and preictal areas respectively. The preictal phase is of utmost importance to neurologists as it indicates that a seizure will occur soon. Thank you very much for watching this video. Please follow us on LinkedIn and Twitter.